Welcome to Combining Like Terms. Um, Today we're going to be talking about combining them, adding or subtracting terms that are like, but we have to know what like terms are. So first, like terms, that's when a variable and an exponent match. So when two terms have the same variable or the same letter and the same exponent, those are like terms. Go ahead and take a second to write this down. And here are some examples. We have 3x and 7x. These are like terms. They have the same letter and the same power. Same thing here. Y and 3y have the same letter and the same power. And then down here, 2x to the third and 4x to the third have the same letter and the same exponent or the same power. When we go through and look at example 1, it says to simplify. And what we have to do is go through the PEMDAS process, just like we were doing before. Now, the first thing is parentheses, and we do have parentheses here, but there's not anything that we can do because these are not like terms. X and 6 are not like terms, so we can't combine them. The next thing that we're going to do is exponents. There's no exponents that we can deal with here. And then we have multiply and divide. We do have multiplication because we have 2 and then parentheses x plus 6, and that means multiply. So we're going to do the distributive property and multiply 2 times x and then 2 times 6. So here I have 2 times x is 2x, and then 2 times 6, which is 12. And then I'm going to bring down 4x minus 1. The next thing I'm going to do is look for like terms. I have a 2x and a 4x here. Those are like terms. And then I have 12 and negative 1. Those are like terms as well. We want to take the sign with it. This is a negative 1. All right, then I combine those. 2x plus 4x is 6x. And then 12 minus 1, or 12 plus a negative 1, is going to be 11. I cannot combine these two things because these are not like terms. So my final answer is 6x plus 11. Go ahead and try exercise 1. Okay, I'm going to do exactly the same process. I'm going to start with multiplying 3 times 4x and 3 times 2. 3 times 4x is 12x. 3 times 2 is 6, so that's where I got these two numbers from. Then I'm going to bring down the 2x plus 4. Next, I'm looking for like terms again, so I have 12x and 2x. And then I also have 6 and 4. Those are like terms as well. 12x plus 2x is 14x, and then 6 plus 4 is 10. I cannot combine the 14x with the 10 because those are not like terms. So my final answer is 14x plus 10. With example 2, this looks a little bit different because I have two different variables. I have x's and y's. Now, as I go through this, I want to make sure my final answer has the variables in alphabetical order. So x is first, then y's. So I'm going to deal with those x's first. I have a 3x and a negative 1x. And then, excuse me, and then I have a 4y and a 2y. The 3x and the negative 1x combined, 3 minus 1 is 2. And then I have 4y plus 2y, which equals 6y. Now, these do not have the same variable. They don't have the same letter, so we can't do anything. We cannot combine those. So our final answer is 2x plus 6y. Go ahead and try exercise 2. So I'm looking for the same thing. I'm starting with my x's first. I have 2x and a negative 3x. And then I have 5y and negative 2y. So I'm going to start with combining my like terms here. The 2x minus 3x is negative 1x. And then 5 minus 2, 5y minus 2y is 3y. Again, I have x's and y's. So we cannot combine them because they're not like terms. So that is our answer here. Now there is a 1x here. I don't need that 1x. I can write the answer as just negative x plus 3y. If it's just a 1, we don't really need it. Example 3 looks a little bit different as well. Now with this one, all of these have x's, so the letter's the same, but the variable is not, or the exponent is not. So I have a 3, I have a 2. When there's not 1, that's a 1 there. So I have different exponents. So I'm going to go through and find those exponents. And again, when I'm writing my answer, this time I'm going to put them from the largest exponent to the smallest exponent in that order, largest to smallest. So I'm starting with x to the third. So that's my biggest exponent. So I have 6x to the third and negative 2x to the third. 6 minus 2 is 4. So then I have 4x, and I don't do anything with the exponents. I don't add the exponents together or anything like that. So it just stays x to the third. Next, I have 4x to the second and 3x to the second. So 4 plus 3 is 7. And again, I don't do anything with the exponents. It's x to the second. And the last one is 3x minus 4x. 3x minus 4x. 3 minus 4 is a negative 1. When I write my answer, again, I don't have to write that 1, and I actually prefer not writing it. So it's going to be 4x to the third plus 7x squared minus x. And again, those aren't like terms, so I can't combine them. Go ahead and try exercise 3. All right, again, I'm looking for the largest exponents. I have a 2x to the third and 4x to the third. I'm going to combine those. 2 plus 4 is 6. And then I have x to the thirds. I look next at the x to the seconds. I have a negative 2 and a positive 3. So negative 2 plus 3 is going to be a positive 1x squared. And then I go to the x's without the exponent. So it's 3x minus x, which is going to be 2x. Again, I cannot combine any like terms here. So there's nothing else I can do. And my answer, I'm going to write it without the 1 there, is 6x cubed plus x squared plus 2x. Now look at example 4 here. Steve went through one of these problems, did all of the work. We want to figure out if Steve is correct. So go ahead and try to figure that out, see if he's correct, and see what he did wrong. Okay, so when I see somebody else's work and I'm trying to check to see if it's correct, I'm going to redo the problem from the beginning. So I just rewrote the whole problem just like it was, and I'm going to start looking for my like terms. So I have 5x squared plus 12x squared, which gives me 17x squared. I'm going to look over here and see what he did. Now he has the 17x, but he wrote to the fourth power, which means he added those two exponents, which you're not supposed to do. So there's his first mistake. Next, I'm going to look at the negative 3x and the negative 7x. So I have negative 3x and negative 7x. That's negative 10x. Now, Steve did that correctly as well, but again, he added the exponent, so that is not correct. And then I have a negative 20 here. There's nothing I can do with that. There's no other terms like that, so I just bring it down. And he did that correctly. Next thing I'm going to do is look. I don't have any more like terms here. So this is actually going to be my final answer. Nothing else I can do. I'm going to look at Steve's work. Now it looks like Steve added all of these together. Except for he added instead of subtracted, and there's all kinds of mistakes. He added even though they're not like terms. So he had a lot of mistakes here. So is Steve correct? No, Steve is not correct. And he combined the like terms that were not like terms. So he combined terms that were not like, as well as adding the exponents, which you shouldn't do.